The TMINI miniature robotic system is CT-based and uses the T-Plan software to auto-segment the patient's bone model for planning resections and implant placement. It will set and confirm the distal femur resection landmarks. These are the most distal points centered on the condyles. Finally, we'll set and confirm the posterior femur resection landmarks, which are set to the most posterior points centered on the condyles. Now we can adjust and confirm our implant placement to match the prescribed kinematic alignment resections to match the thicknesses of the Medacta SpheriKA femur implant thicknesses. We will assume the cartilage to be 2 mm thick, and since this is a CT-based system, we will set our resections to include that assumed cartilage thickness as part of the total resection thickness. With the completed plan for our kinematic alignment resections, you can now proceed to your standard incision and exposure. I will now make 2 stab incisions on the tibia for the tibia tracking array to be placed extra-incisionally. The TMINI system has an overhead active tracking system to avoid side line of sight disruptions, so the arrays are pointing upwards toward the overhead camera. Next, the femur tracking array will be installed intra-incisionally on the femur with the femur array pointing upwards to the camera as well. To begin registration, a simple flexion-extension axis is taken by flexing and extending the hip. Registration continues by using the wireless digitizer. The digitizer's pistol grip design makes it easy to obtain or undo registration points with the A and B button, respectively. Initial registration is done by placing the digitizer tip on subchondral bone in the anatomic location shown on the TMINI navigation console screen and pressing the A button. Next, fine registration is completed by taking the prescribed points in the blue boxes seen on the screen. Again, the digitizer tip should be pressed through the cartilage and on subchondral bone before capturing. Guiding the digitizer tip with your fingers and changing hands are 2 helpful tips to capture all points efficiently. Now the CT-based TMINI system's verify registration can be leveraged to get a measurement for the actual cartilage thicknesses to confirm our earlier 2 mm thickness assumption. Placing the digitizer tip on the cartilage surface in the same location as the resection landmarks set on the T-Plan software confirms here that the distal medial and distal lateral femur cartilage thicknesses are in fact 2 mm. With the digitizer tip placed on the posterior medial and posterior lateral femur, we can actually see that the cartilage is 3 mm thick on both condyles as opposed to the 2 mm thick assumption made earlier. Now we'll register the tibia. Similar to the femur, there is an initial registration that takes 5 anatomic landmarks as well as the medial and lateral malleoli. Tibia fine registration is then completed by selecting points inside all the prescribed blue boxes on the model shown on the TMINI navigation console screen. The tibia verify registration screen is now used to measure the actual cartilage thickness of the tibia at the resection landmarks identified on the preoperative planning software. This patient's proximal medial tibia cartilage thickness is only 1 mm, whereas the proximal lateral tibia cartilage thickness is 4 millimeters. Here we can see that our earlier cartilage thicknesses of 2 millimeters did not hold consistent for all compartments measured. The actual measured thicknesses we obtained are shown on the right-hand side, and we'll now need to make plan adjustments to compensate for these actual thicknesses. To adjust the resection thicknesses to match our confirmed cartilage thicknesses, we'll start by adjusting the tibia. First, I'll adjust the tibia such that there is a 3 millimeter difference between the medial and lateral resections, and then proximalize the construct until our medial resection accurately reflects 9 millimeters and lateral resection reflects 6 millimeters for a total of 10 millimeters total resection thickness target. The distal femur resection thicknesses do not need to be adjusted as the cartilage was confirmed to be 2 millimeters thick and the total resections still equal the 9 millimeter target. Finally, the posterior femur resections are reduced to 5 millimeters to reflect a 3 millimeter cartilage thickness measurement for a total of an 8 millimeter resection thickness. Now I can additionally see on these mobile models that adding a bit more flexion on my femur will ensure that I'm not at risk for notching and that I'm happy with the overall implant placement. The TMINI robot is now brought into the operative field, and as you can see, it is a handheld wireless robotic handpiece. The updated plans will quickly transfer from the navigation console to the TMINI robot automatically. The TMINI robot is designed to only provide power to the chuck to place 6 pins when it is in the correct plane according to the CT-based plan. With the horizontal lines parallel and full power to the chuck, the first pin is placed medially for the distal femur resection. A second pin is placed on the same plane to accommodate the universal cut block provided to complete the distal femur resection. The universal cut block is used for both the distal femur and proximal tibia resections. Surgeons can use their typical 1.27 mm saw blade to perform the resection. To provide confirmation for this robotic KA workflow, we'll take a caliper measurement of the bone cuts to verify the resections. The distal medial and lateral resections both measure 8 millimeters. Now we'll proceed to placing the TMINI pins for the Medacta GMK SpheriKA and SpheriKA guide block. Similar to before, the TMINI robot will provide power when we're in the plane set by the CT plan. With the pins placed, the guide block is placed flush on the cut of the distal femur. 2 pins are placed in the guide block holes that align to the Medacta 4-in-1 cut block such that it will be placed according to the CT-based plan. The Medacta 4-in-1 cut block is placed on the pins and secured. The posterior femur resections are performed first to verify thicknesses. The posterior medial resections both measure 7 millimeters. You can now continue by completing the 4-in-1 resections to finish the femur preparation. The TMINI robot is used once again to place the 2 TMINI pins for the proximal tibia resections using the universal cut block. First, the medial pin is placed, then the lateral pin with the robotic handpiece. The universal cut block is used again to complete the proximal tibia resection. The tibial wafer is now measured with calipers, taking care to place the caliper at the same locations as the resection landmarks from the preoperative plan. Both medial and lateral sections are measured to be 9 millimeters. With all our resections measured, we can now confirm that the actual resections matched our preoperative plan. In the plan, the measurements from the TMINI system are added to the actual cartilage measurements we took for the total resection because it is CT-based. You can still perform your manual checks with the Medacta provided spacer blocks. In this case, I can see I have a great medial pivot balance in flexion and extension. I am happy with the stability felt in this manual check. You can now proceed to finish preparation of the tibia and femur for the placement of trial implants. With the trial implants in, I can now do my typical manual stability checks. The TMINI system also lets you visualize your stability throughout the full range of motion, as you can see here. This shows a nice and symmetric equal medial and lateral gap throughout motion, demonstrating a well-performed and stable kinematic alignment case.